All right, another episode of AP Calc Social Distancing Edition. Broadcasting live from my basement here. So I've got the kids jumping in and interrupting this thing. Anyways, got an example of a Khan Academy problem. Um, got our original differential right here, dy dx. The derivative of y with respect to x equals negative 1/3 x cubed. Well, the first thing we want to do is we want to get all the x's to one side and the y's the other side. Well, there are no y's. So what we're going to do is we're going to multiply the left side by dx and the right side by dx. And then we're also going to get this negative 1/3 to the other side. So we got something to differentiate with respect to y, even though we wouldn't have to. Okay? So we multiplied each side by dx. The dx is canceled here, showed up over here. You multiply each side by the reciprocal of negative 1/3, which is negative 3. That cancels out your negative 1/3 here. It's gone. But it makes our negative 3 show up over there. Well, we want it to be an equation we can solve for y. Well, right now, there's no y's. How can we make a y show up? Well, let's get the integral of each side and see what happens. We separated, now we integrate. So, we're going to find the integral of each side of the equation. Well, what's the integral of negative 3 with respect to y? That's going to be negative 3y plus c. And what's the integral of x cubed with respect to x? That's going to be x to the fourth over 4. So we've got those. Oh, plus c. Now, there's not a plus c here. Okay. But what we would do is there'd be negative 3y plus c. Subtract that c from each side, and we would have a new c in this spot. So we've taken the c that's here, and we've put it on the other side. All right, so now we just have to go and divide by negative 3. So this is going to become a negative 12, and then this is some constant divided by negative 3, which is still some constant. And that ends up being our solution. Y equals negative x to the fourth divided by 12 plus some constant. In some future lessons, what we're going to be given is an xy coordinate that works for your equation. And what you have to do is you have to plug that coordinate in and solve for c so you can see what that c is. We don't have to do that quite yet. This is a family of functions right here that satisfies this differential equation. Okay.